All right, so today we're going to be talking about optimization when it comes to the relationship of area and perimeter of a rectangle. So some terms that we're going to be using. Conjecture is a good idea about a pattern. Proof is just a mathematical way to determine that the idea is true. And a counterexample is simply disproving a conjecture that doesn't have a proof. So maximizing the area with four sides. So two different rectangles can have the same perimeter, but different areas. Draw two rectangles that have a perimeter of 12 units, but different areas. So I went 5 by 1, that's a perimeter of 12 with an area of 5. And I went 4 by 2, again, perimeter of 12 with an area of 8. So if I was to complete a conjecture, basically a good idea, well, what would my idea be? A rectangle with a perimeter of 12 units will have the largest area possible if the length and width are, I'm going to go with 2 by 4, which is the example that I have right here. One way to test our conjecture is to provide a table of values. So the perimeter is 12. Okay, well, the dimensions of width and length, if my width is 1, my length will be 5, right? 1 and 1 is 2, 5 and 5 is 10, which is the example up here. The area of that would be 5 units squared. With a width of 2, my length would be 4. Multiplied together, give my area of 8. A width of 3, a length of 3 would give me an area of 9. 4 by 2 again, 8, and then 5 by 1, and then we can't have anything with 6, or in terms of a width, because that would be larger than the perimeter. So conclusion, my conjecture is false. So my conjecture was it would have a 2 by 4, and I know that that is not the greatest area. The greatest area was actually 9 units squared. So given a fixed perimeter, the shape with the maximum area is when the length is equal to the width, or a square basically. To find the dimensions of this shape, rearrange the perimeter formula. So your perimeter formula, I know my perimeter is going to be 4 times W, in which case would be the width. Or a singular width, to calculate a width of an optimal square would be the perimeter divided by 4, because it has 4 sides. And when length is the same as the width. So those would be how you would find the dimensions of this shape, right? We're looking for a square basically. So how do you find the dimensions of a square? Well, all 4 sides are equal. We know the perimeter, we divide it by 4, it gives us one of the sides, all those sides are the same. Length is equal to width. So when we talk about maximizing the area with 3 sides, this is a little bit different. A farmer is building a rectangular pen for his sheep along the side of his barn. He has 20 meters of prefabricated fencing, so it only comes in that 1 meter long. Draw the situation, so the wall, the 2 widths, and the 1 length. So we have the barn here, the 2 widths are here, and then the 1 length. So he's using the side of the barn as one of those perimeter pieces, and what he needs to buy material for are these 3 sides. So do you think the farmer will be able to enclose more, less, or the same amount of area now that the barn is being used as one side rather than using fences for all 4 sides? So if we go table of values, the total length of 3 sides is 20, right? So this side, and this side equal 20 because he has 20. Meters of prefabricated fencing. Well, with a width of 1, so this would be 1, this is 1, that would give us 2. Our length would be 18. So our area, 1 times 18, would be 18. If I have my total area, the total length of the 3 sides is 20, my width is 2 on either side, that means my length is 16, I would have an area of 32. And I keep plugging in, okay, if a width of 4, that would be a length of 12, which would give me 48 units. If I have a width of 5, that means I have to have a length of 10, which gives me 50 units. And then we go back 6 and 8, which would be 48, 7 and 6, 35. And we can see what the areas end up being, right? So circle the row on your table with dimensions that have the largest area. Well, it's right here, 50 units squared. So the dimensions of 5 and 10 give us the largest area when we talk about using 3 sides. So when you only need to cover 3 sides with a given perimeter of a rectangle, the shape with the maximum area has, well, let's look at this relationship. The width is 5 and the length is 10. Well, the relationship between these two, the length is double the width. So the length is twice the width, and we can see that. The most optimal area of everything that we figured out would be with a length of 10 and a width of 5. Well, the length is 2 times larger than the width. To find the dimensions of this shape, again, we have, okay, the full perimeter divided by 4, that gives us our width. But this time, our length must be 2 times the width. So basically, if you know that if you have a 3-sided figure, when you're using a shape, the length must be 2 times the width. That's basically the take-home message here when it comes to maximizing a 3-sided figure. So minimizing the perimeter, make a conjecture about a rectangle with the least perimeter for a fixed area, and use any strategies to test your conjecture. So given a fixed area, the shape of the minimum perimeter is, or the least amount of space around the outside, is the square. Find the dimension of the shape, rearrange the formula. So our area would be W squared, right? So I'm not really too worried about this stuff down here. So go ahead and go ahead and block this out. I don't really need you to worry about this stuff down here, but I will have you focus in on the optimization of 3 sides versus 4 sides. Again, so the big takeaways is that when you have a 4-sided figure, the optimal area is when the width is the same as the length, or the square. The 2-dimensional shape that gives us the most area for the least perimeter is the square. And then when it comes to rectangles, we're maximizing the area with 3 sides. The length is double the width.